Good day, my name is Rufino Aguilar, and this is my presentation for my web application as a final requirement for CMSC 207. Currently, I am connected with the Provincial Government of Bukidnon, the Provincial Informations and Communications Technology Division. So, the formal name of my web application is the Farmer's Profile Information System. We called it the Maguuma app. So the current version is already deployed. The version 1 is already deployed in production. And this presentation will cover my proposal on the version 2. Hopefully at the end of this presentation, I can showcase the prototype that I have been developing for version 2. So the problems encountered were during the operation where there were no IT personnel for MLGU. So there was no one to maintain the servers and the clients on the municipal local government unit. So there were also hardware issues. Lacking hardware, there were no budget for purchasing servers. Viruses were always a problem. The connectivity, meaning the local area network, was not installed for the municipal agriculture office, and loss of data such as corrupt hard drives and attacks of ransomware were present. The system, there was no period or schedule for conducting surveys. Offline transmittals, meaning that each municipality will bring their database file to the province for consolidation. The data quality was also a problem. There were duplicates and erroneous profiles. So with this, the result would have inconsistent reports and would need human intervention for manual validation. The database were bloated, and the manual system focused on the farmers and not on the location or area. The problem with that is in your database, you will have a location or an area wherein there are two farmers that are enlisted for that area. So the last problem would be the connectivity. There was no internet connection on most of the municipalities, and the ISPs in our province cannot provide static IP addresses for the municipalities. So the solution was to come up with an application system. The first version was a desktop application. It is a free integrated survey tool for farmers' profile, which is built on top of the Enhanced Tax Revenue Assessment and Collection System platform. It is designed to establish a link with the Municipal Agriculture Office and the Provincial Agriculture Office to consolidate agricultural data based on the survey. So the application leverages the use of IT as an important tool to come up with informations that are important in decision making. So this is the process flow of the Maguuma app. The first component is the Municipal Agriculture Office, wherein the Maguuma app is installed on the desktop or laptop or servers of the Municipal Agriculture Office. Then the technicians, agriculture technicians, go to the field or the barangays. They conduct the survey, and when they return to the office, they encode the survey data on the system. The data is then transmitted to the province. Because there is no internet connection on the municipality, so the transmittal of the data is manual. The database backup is brought by the municipality to the provincial office, and then the database is consolidated. So random validation is conducted for verification. This is done by the Provincial Agriculture Office. Then the output is then accessible to both the municipal and provincial agriculture office. So consolidated data can now be used for other applications such as web, mobile apps, and GPS maps. So for Maguuma version 1, we introduced a new system, installed a web server, CentOS, on a desktop or laptop, or any hardware that they can provide. We installed the database server, MySQL, and conducted 4 survey periods and consolidated provincial data. So we work with the utmost minimum cost so that all the municipalities would participate. So for this in this deployment, we used open source and whatever hardware they can provide us. For Maguuma 2.0, the proposal was to build a mobile application and to establish a cloud server. This is the Panganod Cloud Bridge project, and GIS integrations, given that a national agency provided us with the satellite image of Bukidnon. So we redesigned the version 2, focus on the area of the farm rather than the farmer, so that we can ID each farm location and minimize redundancies wherein 2 farmers are located on the same location. With that, we can eliminate data redundancy. We will also have monthly report generations. So we also propose to have a farmer's ID. This is an ID card which we will give to the farmers for them to use when they avail of subsidies or projects from the province or from their municipality. So this is the Panganod Bridge project. Basically, we use the cloud servers from DICT to seamlessly connect the Municipal Agriculture Office and the Provincial Agriculture Office. So the problem which is going to be addressed by the Panganod Bridge is the lack of static IP address in the municipal servers. So in this illustration, we see here that for connectivity, each municipal servers or data centers must have a static IP address which is known to the cloud so that the province and municipalities can communicate with each other. Now the problem is that ISPs cannot provide static IP addresses to the municipalities because their infrastructure cannot provide this service. So the Panganod Bridge resolves this issue by introducing the use of WebSockets. So each municipality will have a Node.js application on their servers, which will wait for any request coming from the municipality or other LGUs, or from the province or other LGUs to their servers. Then that request will be served and the data will be transmitted to the cloud. So no data is being stored in the cloud, only on the local data centers. So with this, we can also minimize the cost on the availment of the cloud server. So we have only one cloud server, and the municipality servers will just use the cloud server as a bridge application. Another feature is the GIS integration. When we introduce GIS to the municipalities, the first thing that comes to their mind would be the cost. That is their major concern every time we introduce new technologies. But then we make sure that we use open source technologies. So the trainings also, the province will give trainings to their personnel in using GIS, open source GIS applications. So luckily, we had the satellite image, and our proposal, instead of using geotagging equipments, we are going to print the maps in an A4 paper size, and this will be used, each paper will be ID'd, and this will be used by the technicians to map out the farmers and the farm areas on the field. Later on, we will train them how to draw layers and to digitize on an open source application, Quantum GIS, so that we can have the real picture of the geographic information of that particular area or farmer. We have 3 key motivations for this project. We have G2C, G2G, and G2B. G2C is government to citizens. We use the report for analysis and basis for our seed subsidy programs, financial assistance, and other agricultural activities. G2G is government to government, wherein we generate reports for other government agencies and regional and national offices. G2B is government to business, wherein we provide data to potential investors who are interested to conduct business on our province. For maintenance and sustainability, we adopt the community-based approach so that we can promote the involvement of our stakeholders, the Municipal Agriculture Office and the Provincial Agriculture, on the implementation of this project. In this way, we can encourage them by giving them training, capacity development, so that they will also benefit from the implementation of this project. So this is the demonstration of my prototype. Here on the screen, we have here the local server hosted on our data center, which has a public IP address. This public IP address. So this is our cloud server. We have a Node.js application. So I used PM2 to manage my Node applications in this server. So we have here a running Panganod cloud server, and we can see the logs of this server through this command. Okay, so we have here the logs of the server. Now we have also here the municipal eTrack server, which is running locally on the municipal server municipal server. We have also the Panganod client server, which will communicate the request from other servers, other municipal servers, through the cloud and send the request to our eTrack server, and will make or compose the response that will be passed through the cloud, and then the cloud will broadcast the response to the specific server or to other clients. Okay, so I have also developed a prototype Ionic application, which is a progressive web application, and now it is running on the browser, but later on we will deploy the Android application to our municipality so that they can use this application in conducting surveys remotely, or they can use also the browser-based application in their computers or laptop in the municipality. So here we have the application. We can log into the application using our test account. Okay. So this account will be validated in our cloud server here. So we log in. So the cloud server acknowledges the login. Then our client server also acknowledge that there is a connection here, client 1, which is this Ionic application. Then immediately it will load the dashboard. So this dashboard loads a request or initiates a request to the specific server. In this example, the Bukidnon server through the cloud. Okay, here request from client 1. Then the client server will cloud server will recognize the request, process the request, and send that request to eTracks. Now the eTracks will process the request, execute the queries, and then send the response back to this cloud application or this client. Then this client will compose the response and send the response to the cloud server through WebSocket that will be broadcasted to all the clients. Example this Ionic client. So we have here a simple application showing the dashboard showing statistics of the farmers data from the Maguuma version 1 survey. So here are the data, sample data. These can also be used to validate the profile of the farmers by enabling them to use this search facility. They can search for the farmer's ID or search by name or location. So that's it for my web application. Thank you.